Assalamualaikum and hi. My name is Muhammad HAKIM bin KAMARUZAMAN and my partner SOLEHAH ALBAT. We are going to discuss about long span structure and DOM. Let's start. Definition: structure with span larger than 50 to 20 meters are regarded to as long span structure. For such structure, span is unable to be achieved with ordinary RCC construction. As you know, RCC is reinforced cement concrete. Generally, long spans result in flexible, column-free internal space, reduce substructure cost and time to erect the structure. There are a few common structural systems for long span structure, such as long span beams, long span trusses, and long span roof structure. Long span beams. The use of long span beams results in a range of benefits, including flexible, column-free internal space, reduced foundation costs, and reduced steel erection times. Many long span solutions are also well adapted to facilitate the integration of service without increasing the overall floor depth. There are few types of long span beams, such as parallel beam approach, composite beams with web openings, cellular composite beams, tapered girders, and hunched composite beams. This is two photos to show that parallel beam approach. Okay, the parallel beam approach is effective for spans up to around 20 meters. Floor grids comprise two layers of fully continuous beam running in orthogonal directions. Service running in either direction can be integrated within these two layers, so that service passing in any direction can be accommodated within the structural floor depth. A further benefit is that, being fully continuous, the depth of the beams themselves is reduced without incurring the expense and complexity of grid full strength connection. As you can see in this photo is a composite beam with web opening. The appearance of this structure is the same as I explained on the previous slide, which is the parallel beam approach. What different it is that this composite beam has holes and its function is the same as a beam. Web openings are typically formed in beam to allow service to pass through the beam. This enables the structural and service zones to occupy the same space, thereby reducing the effective overall depth of floor construction for a given spanning capability. Opening may also be formed for aesthetic reasons, for instance, with camber beams used to support a roof. Composite beam with web opening have been shown to be a cost-effective solution for span in the range 50 to 30 meters. This is cellular composite beams. Cellular beams are a form of beam with multiple regular web openings, formed by splitting two roll sections longitudinally to form two T sections. The two T's, which may not come from the same donor section, are then welded together to form an I section with web openings which have a characteristic shape, normally but not necessarily cellular. This is tapered girders. Tapered girders can be a cost-effective solution in the span range 50 meters to 25 meters. They are another solution that allows service to be accommodated within the structural flow zone. The depth of the girders increase towards mid-spin, where applied moment are greatest, thereby facilitating hanging service under shallower regions near the beam support. It is also possible to form wet opening in tapered girders in region of low shear towards mid-spin. This provide more option for service integration. Hunch composite beams. Hunches may be added at the end of a composite beam to provide moment continuity. The stiffness and strength of the connection means that the rest of the span can be shallower, means the bending moment diagram is lift and the effective stiffness of the beam substantially increase, and service pass under it. In building where the service are likely to need frequent replacement, for example like hospital, hanging the service under the beams rather than passing them through hole in the wall or throughout the truss can be advantageous. Span in excess of 20 meter can readily be achieved. Long span trusses. A truss is essentially a triangulated system of straight interconnected structural elements. The most common use of trusses is in buildings where support to roof, the floor and internal loading such as services and suspended ceiling readily provide. The main reason for using trusses are there are type of long span trusses: bread truss, warren truss, knot light truss, sawtooth truss and fin truss.
Bread truss, commonly used in long span building ranging from 20 meter to 75 meter in span. In a conventional bread truss, diagonal members are intentioned for gravity load. Bread truss is used where gravity loads are predominant. An alternative bread truss is shown where the diagonal member are intentioned for uplift loads. This type of truss is used where uplift loads are predominant, which may be the case in open building like aircraft hangars. It is possible to add secondary members to create intermediate support points where applied load and or limit the backing length of member in compression. Next is warren truss. For this truss, diagonal members alternatively in tension and in compression. The warren truss has equal length compression and tension web members and fiber members than a bread truss. Also, if it is modified, may be adapted where additional members are introduced to provide a knot at, for example, purlin location. It is commonly used in long span building ranging from 20 to 100 meter. Besides, it is used for the horizontal truss or gantry crane girders. As you can see on this picture, it is a knot-light truss, usually used for short span in industrial workshop type buildings. It allows maximum benefit to be gained from natural lighting by the use of glazing on the steeper pitch, which generally faces north or northeast to reduce solar gain. On the steeper sloping portion of the truss, it is typical to have a truss running perpendicular to the plane of the knot-light truss to provide large column-free spaces. Next is sawtooth truss, or can be called butterfly truss. It works similar to the knot-light truss, which used in multi-bay buildings. It is typical to include a truss of the vertical face running perpendicular to the place of the sawtooth truss. And for the fin truss, it is offer economy in terms of spill weight for short span high pitch roof, as the members are subdivided into shorter elements. There are many ways of arranging and subdividing the carved and internal members.
Next slide is long span roof structure. It is built as a wide range of buildings that are entirely self-supporting with no trusses, frames, support posts or purlins. It is a structural curved skin covering a given plane shape and area where the forces in the shell or membrane are compressive, and in the restraining edges, beams are tensile.
Suitable for factories, warehouse, agricultural buildings, hangar, large shops, public halls, gymnasium, and arenas. There are a few types of long-span roof structure. It is a tensile structure, folded plates, shell structure, and portal frames. Tensile structure. A tensile structure is a structure that is established by tension rather than compression, such as a piece of fabric pulled in opposite direction. It is usually achieved with wire or cable opposite by compression elements like mats, ring beams, and ground anchors. Tensile structure use less material than conventional compression structure. It is more lighter and can span larger distance.
For the next slide is folded plates. The folded plate structures are assemblies of flat plates or slabs inclined in different directions and joined along their longitudinal edges. The structural system is capable of carrying loads without need for additional supporting beams along mutual edge. In addition, folded plates are economical over long span that need to be free of internal columns and other obstructions. As you can see in this picture, it is a shell structure or thin shell structure. These materials are lightweight construction using shell elements. These elements typically shaped, curved, and assembled to make a large structure. The shell structure typical application include aircraft fuselages, boat hulls, and roof of large building.
Portal frames, commonly used to create wide-span enclosures where a clear space is required uninterrupted by intermediary columns. It is the simplest form that characterized by a beam support either end by columns. However, the joint between the beam and columns are rigid, so the bending moment in the beam is transferred to the column. Portal frame, a form of structure that weatherproof enclosure at low cost with little material.
For this part, we explain about the consideration of factors that must be taken of the selection and designing a suitable roof structure. It consists of function of the building, span of the roof, height of the space, aesthetic and design requirements, economics consideration, construction consideration, and the environment. The material used for a long span structure is steel, concrete, aluminum, plastic, and timber. The material used depends on the strength to carry load and weight of the material. For the material used, firstly is steel. It has high strength in both compression and tension, can up to 280 Newton, and a small amount of material is able to carry large load, and it is more adaptable than reinforced concrete if alternation are necessary. Also, it is comparatively easy to strengthen the structure. Next is concrete. Its more compressive strength of 20 to 60 Newton, and it generally requires less maintenance than steel, which must be painted periodically. Effectively used in structural form, which can take advantage of its monolithic character, particularly three-dimensional forms such as shell, doubly curved slab, and folded slab. For the other material used is aluminum. It's the third of the weight of steel and corrosion resistant, but a bit expensive. Anyhow, it is economically used in cases where weight of the structure itself from a substantial part of the load and the imposed loads are comparatively light. Moreover, aluminum are highly corrosive atmosphere, and it may be more economical to use it instead of steel to reduce maintenance costs. For the next material used is plastic. Plastics as well light in weight of only about 1/6 of the weight of steel. The plastic material are suitable for space structure of the stressed skin type in which the strength is derived from the geometry of the form, then from the properties of the material such as geodesic dome and grid structure. Material use of timber. It is the first material to be used. Thus, the development in methods of joining timber, stress grading of timber, improved method results in the more efficient use of material. However, timber material are shorter span than steel or concrete, and the light material and weight approximately 1/16 of steel.
For this project, we choose Kuala Lumpur International Airport as the case study. The Kuala Lumpur International Airport KLIA in Sepang, Malaysia is one of the largest airports in Asia. Kishore Kurokawa designed the KLIA with traditional style and aesthetic with cutting-edge technology. The Islamic style traditional shading roof is also similar to the tree of Malaysian rainforest, with narrow skylight in between the trees. The functions are laid out on a rational grid with symmetry and modern feature, comfort and amenities combined, as this geometry combined with the organic nature of a forest. Structure opens up space as widely as possible.